Okay, so we look at ratio in terms of gears. So if you look, there are different size of gears, and what ratio means in this case is when this gear rotates one time, how many times does the other gear rotate? I mean, you can of course keep it static, and that's one way, but you can also just rotate it around one revolution, two revolutions, three revolutions, four revolutions. It's a little more than four, maybe 4.5 revolutions. So every time one of the gears rotates once, how much does the other gear rotate? The other is of course to rotate both the gears. So that's also fine. When will they come back, right? So one revolution for the small one is done. Two revolutions are done. And that's three revolutions. So every time the big gear rotates once, the small gear rotates 3 times. Right? So that's the ratio here. So this is every time this rotates once, this rotates 3 times. So let's go back and look at this one again. Yeah? They're together, and then we start rotating. One time, 2 times, 3 times, 4 times, maybe about 4.5. So let's see how these two pair up. So this is like every time this rotates, this seems like 4 or 5. And there could be some error, of course, right? So I'm just say it's between 4 and 5. Between that. It almost looks like a 4.5, which is fine too. Let's compare these two. And this basically depends on the number of cogs that I have. That's it, right? So the number of cogs I have here, perimeter, versus the number of cogs here, perimeter of that. So again, we get both the things sort of in the center, both of them are looking at each other, and then we start rotating. It's 1. Yeah, so this has rotated once, this is rotated 1.5 times it seems. So if it's really 1.5 times, if I keep rotating, then at 3 they should come together, right? So that's 1.5 of the small one, this one. It's 2 of the small one, and they have come together, and this has rotated 2 times and this has rotated 3 times, right? So then if you had taken the ratios together, this one to the small one was 1:3. This one to the large one is 1:4.5. We kept getting 4.5. And that makes sense, because if this one, so if these two are together, this one would have rotated 3 times every time. Maybe I should have used colors like that. This one rotated once, and now this one's rotating 3 times. So with the big one and the small one, when it's rotating 2 times, this is rotating 9 times. So that is actually 1:4.5, isn't it? When I'm comparing this one, the big one, with the small one, I'm getting the same ratio as I got before. So ratios can be used with gears, and you can have a lot of fun discovering what the relationship between the different gears are. And then of course you can build something with putting a stick in, and these all have screws, so you can actually put it in and screw it, and then you can rotate one and see what happens to the other, and so on. And we also have some gearboxes, so you can open up gearboxes and see how they are inside. For example, in the big shot cameras, or with even the gearbox based motors, so they will all have gears inside which we can look at and understand in this way.